Hi guys, welcome back. So today we're on until 10:40. So this is the 2-hour class today. We should get through the next two lessons, so 6.4 and 6.5. If we can get to 6.6, then we get to 6.6. If we don't, then we don't. So these are the last three lessons for Unit 6. So we're basically done trig after this, and then we move on to logs, and then rates of change is our last unit. So I'll do the two lessons, and then if you guys have questions from yesterday, I'll answer those after. But right now we're going to get through our trig identities and our linear trig equations. So last year you guys learned the basic trig identities, which were tan of x is equal to sine over cosine. Cotangent is equal to cos over sine. You have your reciprocal identities, which is cosecant is equal to 1 over sine x. So I'm just going to write these down from what you learned from last year. So this is from grade 11. So tan is equal to sine over cos. Cotangent is equal to cos x over sine x. Do you guys remember any other ones you guys learned last year? Sine squared plus cosine squared is equal to 1. That should have been taught last year. And the reciprocal identities. So cosecant x is equal to 1 over sine x. Secant x is equal to 1 over cos x. And cotangent x is equal to 1 over tan of x. Okay, so as you can see, last year's equations were pretty simple. Didn't have much to use, but because we introduced the addition and subtraction formula, so the compound angles and the double angle formulas, those are all fair game as well when it comes to solving for trig identities. So some rules to solving trig identities is to try to change tan x and cotangent x to be written in terms of sine and cosine. Okay, so if you ever see a tangent and a cotangent, always try to change it to sine or cosine. It's just going to make your life easier. Move from the more complicated side and simplify that, because when there's a trig identity, there's always one side that is more complicated than the other. And we want to use all of our identities, including the double angle formulas, the addition and subtraction formulas, and the Pythagorean identities, which we just discussed, which is sine squared x plus cos squared x is equal to 1. Secant squared x is equal to 1 plus tan squared x. And cosecant squared x is equal to 1 plus cotangent squared x. So these last two over here are new from last year. The one above is from last year, and the ones I wrote down are stuff you should have learned last year as well. Okay, so like I said, when it comes to trig identities, there's always one side that's more complicated than the other. So we might as well just focus on that side as opposed to trying to simplify both sides. So we want, for our first example, we want to prove that secant squared y, or secant squared x minus secant squared y is equal to tan squared x minus tan squared y. So let's just take a look at our left side. Let's see if we can make it equal to tan squared x minus tan squared y. So what identity includes secant squared? Which identity are we going to use? If you guys want to unmute your mic and say the answer as opposed to typing it out, that's probably 100 times easier. So it's 1 plus tan squared x. So we have 1 plus tan squared x minus 1 plus tan squared x. So now what we have to do is we're going to flow the negative into our bracket over here. Sorry, 1. So this is a y. So we get 1 plus tan squared x minus 1 minus tan squared y. So when we simplify it, the 1's cancel each other out. And we're left with tan squared x minus tan squared y, which is what we wanted. We got the left side is equal to the right side. Is this simple? So was this a simple example so far?
Yeah.
Okay, perfect. So now let's move on to our second example. So remember, we're not doing anything complicated. We're just basically finding identities that are equivalent to each other so that we make our lives easier to solve for the identity. So the next example we have is prove that secant x minus cos x times cosecant x minus sine x is equal to tan x over 1 plus tan squared x. So let's start with the left side first and see if we can make it equal to the right side. So let's focus on this side first. So on the left side, we have secant x minus cos x times cosecant x minus sine of x. So what would our first step be into simplifying this left side? Do we have any trig identities on the left side that we can use? Okay, so we're going to use the reciprocal identities. So secant x is 1 over cos x. And cosecant x is 1 over sine x minus sine x over 1. So what would our next step be? So we want to find the common denominator. So in the first bracket, the common denominator is cos of x. And in the second, the common denominator is sine of x. So the first one, has a common denominator of cos x. And the second one has a denominator of sine of x. So we get 1 times 1 minus cos x times cos x. And here we got 1 times 1 minus sine x times sine of x. So when we simplify, we get 1 minus cos squared x over cos of x times 1 minus sine squared x over sine of x. So what would our next step be? I'll give you a hint. Use the, which one is it? Use the identity that has sine squared plus cos squared x is equal to 1. So your hints here is sine squared x plus cos squared x is equal to 1. So what can I do to simplify my numerators for both fractions? So all we would have to do is rearrange that identity so that we can get an expression of sine squared x or cos squared x is equal to 1 minus something. So if we rearrange this in two ways, we get sine squared x is equal to 1 minus cos squared x, and we get cos squared x is equal to 1 minus sine squared x. So because our numerators, both of them involve both of them, we can simplify the numerator in the first. So 1 minus cos squared x is equal to sine squared x. So we get sine squared x over cos x multiplied by cos squared x, since cos squared x is equal to 1 minus sine squared x, divided by sine of x. So what happens when we simplify this even more? What is the answer that we're left with? So the identity sine squared x plus cos squared x is equal to 1. You can rearrange it in any way because that in itself is an identity. So if we isolate for sine squared x, we are left with 1 minus cos squared x. And if we isolate for cos squared x, we have 1 minus sine squared x. Okay? Because all we're doing is, so let me just start from scratch. So you have sine squared x plus cos squared x is equal to 1. If we want to isolate for sine squared x, we have to move the cos squared x over. And when we move that over, it becomes a negative. So we get sine squared x is equal to 1 minus cos squared x. So sine squared x is equal to 1 minus cos squared x. That is another trig identity. And as you can see, we have 1 minus cos squared x in our numerator in the first fraction. So we can just say 1 minus cos squared x is the same thing as saying sine squared x. And it's the same thing when you're isolating for cos squared x, you get 1 minus sine squared x. So is this in simplified form already, or can we break it down even more? So you can simplify, and what are we gonna simplify even more? Not necessarily, it has to do with the exponents. Jose, you're unmuted. If you're going to say something, say it.
All right.
So as you can notice, who's going to say something?
You can divide the sine x from the sine x squared and the cos from the cos x squared.
Yep. So all you're really doing is just basically simplifying the exponents. So we have sine squared, because they're being multiplied, you can do that. So we have a sine squared x in our numerator over here, and we have a sine x over here. So remember our exponent laws. If you're dividing exponents, you're subtracting them, okay? So basically all you're doing is you're cutting this exponent down to 1, which cancels out the denominator. So you're just left with sine x. And you're going to do the same thing with cos x. This exponent gets reduced to 1, which cancels out the denominator. And we're left with sine x times cos x as our left side. And obviously, as you can see, left side does not equal the right side yet, which means we have to also simplify the right side. So now we're going to look at the right side, and where we have 10x over 1 plus 10 squared x. Or, to make it easier for you guys, we get 10x divided by 1 plus 10 squared x. So what is the first identity we're going to use on the right side? What's the easiest one right off the bat? So yes, Jose, we're going to use sine x over cos x. And is there any identity for 1 plus tan squared x?
Would it be secant squared x?
Pardon?
Secant squared x?
Yeah. So we got secant squared x. So right now we have sine x over cos x divided by secant squared x. So what would our next step be? Is there an identity for secant squared x? So 1 over sine x, but because secant squared is to the power of 2, it'll be 1 over, not sine x, but remember, secant doesn't correspond with sine. Cosine. So you get sine x over cos x divided by 1 over cos squared x. Now we have to flip the second fraction. And when we simplify that, what is our final answer? So you have sine x over cos x times cos squared x over 1.
Sine x times cos x.
Yep. Thank you, Yusuf. So we get sine x times cos x. And now we can say the left side is equal to the right side. So our trig identity is terrible, or not really anymore? Not that bad for now. The next example is going to be a pretty lengthy one. So let's see if your answers change when we do the next example. So we have our third example. We want to prove that cos 2x over 1 plus sine 2x is equal to tan of x of pi over 4 minus x. So what type of trig equations do we have, or what type of formula do we have on the left side? So we have double angle formulas on the left side. And what do we have on the right side? What kind of formula do we have on the right side? On the right side, we have a compound angle formula. So just based off these two different formulas we are going to have to simplify both the right side and the left side. So let's start with the right side. So on the right side, we have our subtraction compound formula for tan. So this is just going to give us tan of pi over 4 minus 10x divided by 1 plus tan of pi over 4 times tan of x. So let's see if you guys remember this quickly. What does tan of pi over 4 give us? 1. So we get 1 minus 10x over 1 plus 1 times tan of x, which is just the same thing as saying 1 minus 10x over 1 plus tan x. Or let's change the format of this to make it easier. 1 divided by 1 plus 10x. So the reason I like doing this is because I don't want to be stacking fractions on top of each other, because for some of us it may be confusing. But if you want to stack fractions on top of each other, go for it. I'm not opposed to you guys doing it. Me putting the division sign is just a better way of me seeing what I have to flip in terms of the second fraction. That way I'm not guessing what I'm multiplying what by. So we have 1 minus 10x divided by 1 plus 10x. So obviously we're not done there, because on the first page it's stated that we should change things to sine or cosine whenever possible. So what identity do we have here? No, we do not have secant squared x. So what is the identity for tan x? Sine over cos. So we get 1 minus sine x over cos of x divided by 1 plus sine of x over cos x. So now all we're going to do is take our common denominator. So on the left side is going to be cos x, and on the right side is going to be cos x as well. So we get 1 times cos of x minus sine x divided by cos x divided by 1 times cos of x plus sine x over cos of x. So now what we have to do is flip over the second fraction. So we have cos x minus sine x over cos of x times cos of x over cos x plus sine x. So what is our last step? What is the last step for us to do for this to be simplified? So the cos x's cancel out, and we're left with cos x minus sine x over cos x plus sine of x. So this is our left side. So we're not done yet because we don't have left side is equal to right side. So we need to do, sorry, that's the right side, not the left side. So that is our right side. So now what we have to do is we have to focus on our left side. All right, so now let's look at our left side. So in our left side, we have cos 2x minus over 1 plus sine 2x. So we know we have double angle formulas. So what is the double angle formula for cos of 2x? So for cos of 2x, we have the double angle formula. Cos 2x is equal to cos squared x minus sine squared x. Divided by. And then we have 1 plus sine 2x. So what is the double angle formula for sine of 2x? So we got 1 plus 2 sine x cos x. Thank you, Jose. So you get 1 plus 2 sine x cos of x. So when we look at this, the coefficient of 1 is throwing us off. So we need to somehow figure out what trig identity gives us a value of 1. So what trig identity gives us an equation equal to 1? So sine squared x plus cos squared x. So you get cos squared x minus sine squared x over cos squared x plus sine squared x plus 2 sine x cos x. And this is the part we're going to dislike trig identities because it involves polynomial equations now. So if we look at the numerator, what type of polynomial equation does it look like? So it looks like a difference of squares, okay? So to make it easier on ourselves, let's just put a let statement. We're going to say let x be, let's just say sine x. I'm going to say let y be cos x. Okay, just for your brain's sake, we're going to put let statements because it's going to be easier to visualize. So we got cos squared x minus sine squared x at the top. So we get y squared minus x squared over, and then let's rearrange this to be, so we get x squared plus 2xy plus y squared. So what would our numerator be simplified into if it's a difference of squares? So our numerator would be y plus x times y minus x. And what would our denominator simplify into? Remember, you're factoring a trinomial, so use sum and product. So we get x plus y and x plus y for both. Is there anything that can cancel out? So the y plus x is cancel out, or the y plus x and the x plus y. Because they're both positive, you can rearrange it in both ways. And what we're left with is y minus x over x plus y. And we said our y is cos and our x is sine. So we're left with cos x minus sine x over cos x plus sine of x. And this is our left side, which means left side is equal to the right side. So on a scale of 1 to 10, I guess how easy was this example now that you looked at it and we did it together? Okay, everybody else, all the boys are answering. I need the rest of the class to give me an answer. Okay, so some of you find it easy, some of you find it okay. And like I said, trig identities takes a lot of practice, so don't feel discouraged if you don't get it on the first try. Okay, so as you can see, trig identities does involve quadratics and does involve trinomials. So there is a chance that you might have to factor out a difference of squares or a trinomial when you're doing these types of equations. So just be aware to look out for those, because they're not there to throw you off. They're there to see if you remember the concepts from the previous unit. Okay, so like I said, be on the lookout for any difference of squares or any trinomial factoring when it involves trig identities.